What's that sound? It's for amusement only, the EM and Bingo Pinball Podcast. Welcome back to For Amusement Only. This is Nick Baldridge. I had a request to discuss how to use a multimeter in order to troubleshoot your game. Now, a multimeter can be useful for many things, electrical and electronic. And depending on the era of your game, it's going to be more or less useful. I use a multimeter for a variety of purposes. I use it to test basic continuity. I use it to test resistance. For diodes, I use the diode setting on my meter to test if they are operating properly. And I also test voltages. Now, when you test your meter, it's important to know that you have to have it set to the appropriate function, or you're either going to damage your meter, damage the thing you're trying to test, especially if it's an electronic thing, or get false readings that are not going to be the thing that you're trying to actually test. So, let's start with the simplest thing, and that's testing continuity. If you get a meter that has it, and almost every meter does, a continuity test, when you touch the leads together on the meter, it's going to beep, beep. The longer you touch them together, the longer it beeps. Pretty simple. When you touch the leads to a switch, for example, that is closed, it's going to beep, ideally. If the switch is fouled or is not actually making adequate contact, it's not going to beep. When the switch opens, it should stop beeping. All pretty simple stuff. On an EM, the nice thing about it is that there are typically these large switch tabs which hang off the back of any switch stack and allow you to test both sides of the switch without actually physically touching the leads together, since the leads do, take up some amount of space. What I'm trying to say is it's hard to test a leaf switch by touching the top and bottom of the leaf switch with your leads. It's much easier to test on the back on the solder points. So that's continuity. Again, pretty straightforward, but let's move up in complexity a little bit. Let's say your game has a resistor in order to help reduce spark or reduce the amount of current that is being fed into a coil or something of that nature. A heavy-duty switch, perhaps, that needs the current reduced. You set your meter on resistance, which has a symbol omega in reference to the value that you're trying to determine, ohms. The higher the ohms, the more resistance your resistor has. The lower the ohms, the less. So, in a high resistance resistor, the current flow is impeded in that amount. And as with water, electricity finds the path of least resistance. Now, in some cases, that just means that the electricity is not getting there quite as quickly or with as much force as it would ordinarily, the force being amperage or current, but it's still getting there. So the main thing to remember about ohms is that you need to ensure that you're getting a proper reading. Some meters are auto-ranging, meaning when you touch the leads to either side of the resistor, it's going to figure out that it's mega ohms, kilo ohms, or just plain ohms, and provide you with a reading. Others, you have to actually set it. So, if you have a 400 ohm resistor and you have your meter set on kilo ohms, it would be 0.4 kilo ohms or 400 ohms. You see, you just do the conversion out. Now let's go to testing voltages. In a bingo in particular, you want to test for if the game has appropriate voltage at a particular coil or a motor or perhaps a rivet on a disc. And to do this, you test against common. In a bingo, that is the black wire. And then against whatever else you're testing. So if you're testing a coil, you would put it on the non-common lead of the coil and then test to common and see what the voltage reading is. Now again, voltage can be auto-ranging or you have to select it. And as with everything electrical, everything works in standardized powers of 10. So you can go from micro anything up to mega anything in a game, and that is going to give you your reading. So it's important that you understand how much potential, that's what voltage is, it's potential for current to flow. It's not actually current flowing. And a lot of people make that mistake in conflating the two things. Just because there's a potential for current to flow, it doesn't mean that current is actually going to flow. It just means that it's possible for it to. So, moving on, diode test. Some meters have a dedicated diode test, and what this is going to do essentially is measure the resistance. A diode that's working properly will give some resistance one way and infinite resistance the other. Now, the amount of resistance it gives is called the amount of bias. When you forward bias a diode, the current flows from the banded side to the non-banded side. The banded side is called the cathode. And the current flows from the cathode to the anode, always, except in the case of a Zener diode. So, in a Zener diode, it flows from the anode to the cathode. But I have never seen a Zener diode in an EM machine. That doesn't mean that they don't exist, and I'm really racking my brain here, but I don't think I have ever seen that happen. It's always been just plain old diodes. Diodes come in different flavors. They are most likely not pleasant to eat, though. But the various flavors have different bias points, and when you apply current at a particular voltage, it will allow the current to flow in one direction, and no current should flow the other direction. Now, the problem with diodes is that if you apply enough current in the wrong direction, it will cause the internal resistance, that little jump point that it has that prevents the current from flowing normally. It'll break that down and fuse it together so that the current can just flow right through, and that's what happens. When a diode fails, that's what's going on. The little piece that prevents the current flow is doing that. Now, in a game, if you've got capacitors, that's where things get tricky. Capacitors do what's essentially kind of a quick charge. So when current flows into a capacitor, it's going to hold an amount of current and then discharge it back into the circuit as soon as power is no longer applied. Now in an AC powered game, it's going to allow for kind of carryover through the bottom of the cycle of AC. In a DC powered game, it's going to allow current to continue flowing even when there is no additional current flowing in the circuit otherwise. Testing a capacitor can be done by testing the voltage that is flowing through it. You have to set your meter on voltage and then check really carefully. Your meter has to be pretty darn good in order to get a reading off of a small capacitor. By pretty darn good, I mean pretty darn expensive. I don't go for that, and what I try to do is assume that the capacitor is doing its job until I've proven otherwise by checking out the operation of the rest of the circuit. Basically, I rule out everything else before I replace a capacitor. And that's because, though capacitors fail frequently, it is very difficult to diagnose if they have failed or not using standard cheapo equipment, which is all I use. Now jumping back to voltage for a minute, one thing I completely neglected to mention is if you're testing an AC circuit, there are different settings for AC versus DC. If you have your meter set to DC and you're measuring an AC circuit, it's going to jump all over the place and give you a terrible time trying to read it. So if you're measuring for 25 volts, say in a coil circuit, in a Gottlieb EM, and you have it set to DC, it's going to jump from 25 to 0 to negative 25 to 0 to 25 very, very quickly, and the meter's going to get very confused and will display some random jumble of all that mess. Sometimes you can figure out what it's trying to say, but most of the time, no. And so it's important to set your meter to AC if you're measuring AC, DC if you're measuring DC. And beyond that, really the only other helpful hint I have for using a meter is a habit that I got into back when I started using analog meters, which are a rarity nowadays, but I still enjoy using an analog meter, but find myself using a digital one more frequently. At any rate, with an analog meter, it's important to knock out any residual voltage that may be flying around from lead to lead. And to do this, you just touch the leads together right when you switch it from setting to setting. This will zero out the meter. I do this with digital meters as well, and honestly, I never have that kind of trouble with false reading. If you've been listening for a long time, you know that my cheapo meter was giving me fits in the early days. I've since adjusted that, and now it seems to be doing better, and I've got a replacement as well, and that one works much better. The only downside of the replacement is there's no continuity test, so I still have to drag out the other meter if I want to get the beep. So in an EM game, if you're going to do a repair and you want to verify that there's continuity from point A to point B, that's the most useful feature of the meter. I honestly rarely measure voltage unless I'm checking for a specific problem, which is driving me nuts, like a payout problem on a bingo. Most of the time, I check for continuity. Well, thank you again for joining me. My name again is Nick Baldridge. You can reach me at foramusementonlypodcast@gmail.com. You can listen to us on iTunes, Stitcher, Pocket Casts, via RSS, on Facebook, on Twitter at Bingo Podcast. You can follow me on Instagram at nbaldridge, and you can listen to us on our website, which is foramusementonly.libsyn.com. Thank you very much for listening, and I'll talk to you next time.